Hello student, I am Dr.Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss about red gold. Red gold is new for you people because you don't know about this. Nanomaterials. To understand the red gold, you should know about the nanomaterials. Nanomaterials are materials having nanoscale dimension. Nanoscale refers to less than 100 nanometer. Less than 100 nanometer. Material size less than 100 nanometer, that is called nanomaterial. Then one nanomaterial means 10 to the power minus 9 meter. So small, very small. 10 to the power minus 9 meter is called nanometer. Size of an average human hair, HAIR. Size of an average human hair is of the order of 10 to the power 5. 10 to the power 5 nanometer. Like you can say 1 lakh nanometer. Average human hair is of 10 to the power 5. 1 lakh nanometer. Okay. The nanometer is a substance in which the external dimension of the particle is in the range of 1 to 100 nanometer. Between 1 to 100 nanometer, if any materials, its size is between 1 to 100 nanometer is called nanomaterial. This is very small size. Nanomaterials may be of metals, may be of metal oxide. Metal oxide means when metal will react with oxygen, then it will form metal oxide. Generally, metal exists in the metal oxide. It may be in the form of semiconductors. Semiconductors means that type of metal which can conduct electricity or heat partially, like 50%. That is called semiconductor. Then this type of metal oxide, semiconductor show different physical, optical, mechanical, magnetic properties. They conduct ions, electrons, heat or light differently from the conventional materials. And decrease in size in a nanoscale result in dramatic change in the physical and chemical properties, leading to a new materials. However, it must be understood that new properties enables new applications. Fast progress in today's nanomaterial research is expected to lead in superior materials of tomorrow. In terms of particle size, nanomaterials are in between bulk material and atomic or molecular structure. Nanomaterial, it comes between the in terms of size. Bulk means big. Just like now we have seen nano car in comparison to the ordinary car or big car, it is very small. Here also bulk. Bulk means big, big. And then nano size material, it will come between the bulk and atomic size. Atomic size means here, atom, you can tell, atom is the smallest particle of any matter, a smallest particle of any things which further can't be divided, that is called atom. Then nano size material, that will come between the bulk and atomic or molecular size. They show different physical, chemical, optical, electronic and magnetic properties in comparison to the bulk material. Bulk material will show different properties and nano material will show different properties. In physical properties will be different, chemical properties will be different, optical properties will be different. Optical means light properties will be different, electronic and magnetic properties. They differ in comparison to the bulk material. Bulk materials show change in physical properties as it passes or it reaches. If it become bulk material, when it become small and smaller like that, then when it will come to the size of nano material, then their properties will change. Nano-dimensional materials exhibit different and newer properties than bulk materials because of their small size. What type of properties change and what does influence the material properties? Then it is actually size. As the size decreases, properties will change. All properties will change. Some of the properties that are affected by size are: first, chemical properties. Chemical properties means here catalytic and reactivity. Catalytic properties means reaction can go fast or slow. That will reaction rate of reaction can change. Then chemical properties means here catalytic and reactivity. Second, thermal properties will change. Thermal properties means melting point. Melting point will change. Just like a candle, it will melt quick soon. Ice will melt soon. But iron will melt at a very high temperature. Then that is actually melting point. Mechanical properties will also change. Mechanical properties means adhesion and capillary forces. Optical properties will also change. Optical properties means absorption and scattering of light. Electrical properties will also change. Electrical properties means tunneling current, a special type of current. And magnetic properties will also change. Then magnetic properties means super magnetic effect. Then these properties actually change. In bulk size, its properties different, but same material, when it will reach to the nano size, then their properties will change. Then here red gold is due to that only. It is related to optical properties. Optical properties are connected with electronic structure. A change in zone structure, zone structure leads to a change in absorption and luminescence spectra. This is related to light. Bulk gold appears yellow in color, whereas nano-sized gold appears red in color. When this gold only, what we know, that gold, that is bulk size gold, when it will come to the nano-sized gold, then its color will change. It will look red. What is actually reason for that? The particles are so small. Particles are nano-sized gold are so small that electrons are not free to move about as in bulk. In bulk, electrons will move. In bulk, electrons will move freely, but in nano size, electrons will not move freely. Okay, the particles are so small that electrons are not free to move about as in bulk gold, because of the restrictions in movement. Okay, in nanoscale gold, because of the restrictions in movement, the particles react differently with light. Okay, then this is the reason why it appears red. Gold in nano size appears red due to the restriction of movement of electrons, and when it will move differently, then light will can say light and electrons, their behavior will change. Their light will behave differently with electrons in nano-sized gold, and it will appear red. Now I am stopping only here. Thank you.